This presentation is based on the third edition of the Open Precalculus textbook written by Carl Stitz and Jeff Sager. Chapter 10, Foundations of Trigonometry. Section 10.1, Angles and their measure. I will discuss some of the definitions based on this section. We draw a ray by using a solid dot at one end of a line segment. This dot is called the initial point. At the other end of the line segment, we put an arrow there. As we can see, here is a ray with initial point P. When we use the same initial point to draw two different rays, they form an angle. The location of the common initial point is the vertex of the angle. Here is an angle with vertex Q. There are two extreme cases. Case number one, there is a strict angle when the two rays share the common initial point P and pointing to directly opposite directions. The second case is when the two rays are identical. Then the angle is not distinguishable from the ray itself. The measure of an angle is a number which indicates the amount of rotation that separates the rays of the angle. In simple terms, we want to use a number to describe how big the angle is. However, there may be cases where there are ambiguities. When we have two rays sharing a common initial point, are we measuring the inside between these two rays? Or are we measuring the outside? In order to avoid such ambiguity, we first introduce some Greek letters. We will introduce four of them first: alpha, beta, gamma, theta. With the help of Greek letters alpha and beta and an arc, we indicate which portion is the angle alpha and which portion is the angle beta. One system to measure angles is degree measure. Many of you are familiar with it already. One revolution is the same as 360 degrees. Half of a revolution is 180 degrees, and a quarter of a revolution is 90 degrees. An acute angle is an angle strictly between 0 degree and 90 degrees. Strictly between means it does not include the endpoint 0 degree and 90 degrees. An obtuse angle is an angle strictly between 90 degrees and 180 degrees. There are two ways to subdivide degrees. One way is very common, decimal degrees. An example is 30.5 degrees. Another way is to use degree minute second system. We should remember that 1 degree is equivalent to 60 minutes, and 1 minute is the same as 60 seconds. Then it follows that 1 degree is the same as 3,600 seconds. An example of an angle in degree minute second system is 42 degrees, 7 minutes, and 30 seconds. Two acute angles are complementary if their sum is 90 degrees, as shown right here. Two angles, either a pair of right angles or one acute angle and one obtuse angle, are called supplementary angles if their measures are added to 180 degrees. I will describe the concept of an oriented angle. For any oriented angle, the direction of the rotation is important. We call one of the two rays the initial side and the other ray the terminal side. We imagine the angle being swept out starting from an initial side and ending at the terminal side. Here is an example of a positive 45 degrees angle. The angle is positive by definition when the rotation is counterclockwise from the initial side to the terminal side. On the other hand, this angle is a negative angle and it is negative 45 degrees. The rotation is clockwise as indicated by this arrow. An angle is in standard position when its vertex is the origin and its initial side coincides with the positive x-axis. Angles in standard position can be classified based on where their terminal side lies. For example, if the terminal side lies in the first quadrant, we can call the angle a quadrant 1 angle. If the terminal side of an angle lies on one of the coordinate axes, then the angle is a quadrantal angle. An example of a quadrantal angle is 0-degree angle. Likewise, 90 degrees, 180 degrees, 270 degrees, and so on are also quadrantal angles. Two angles in standard position are called coterminal if they share the same terminal side. This picture shows the two coterminal angles 120 degrees and negative 240 degrees. They share the same initial side, which is on the positive x-axis, and they share the same terminal side. We now go to definition 10.1. The real number pi is defined to be the ratio of a circle's circumference, c, to its diameter, d. Pi equals c over d. This definition agrees with what you have learned before. You probably have known that the circumference of a circle equals 2 pi times the radius, r, and the diameter equals 2 times the radius r. Therefore, pi equals c over d equals 2 pi r divided by 2r, which is correct. Likewise, we can consider just a portion of the circle instead of the whole circumference. We call this portion S. Correspondingly, there is a central angle subtended by this arc. With the radius r, the radial measure of the angle theta is the same as S over r. Or we can remember the formula as S equals r times theta. Keep in mind that theta is in radian measure in order for us to find the arc length S. We move on to equation 10.1, degree radian conversion. To convert degree measure to radian measure, we multiply by pi radian over 180 degrees. To convert radian measure to degree measure, we multiply by 180 degrees over pi radians. Equation 10.2, velocity for circular motion. For an object moving on a circular path of radius r with constant angular velocity omega, the linear velocity of the object is given by v equals r times omega. This is very similar to our arc length formula S equals r theta. Replacing S by the linear velocity v and replacing theta by the angular velocity omega, we get this formula.